Alright everyone, this is problem 2.22 out of Griffiths Quantum Mechanics textbook. Before I get into the solution for this problem, if you wouldn't mind please liking the video and subscribing to my channel, I'd really appreciate it. It's a great way to support me, and I post a lot of content with solutions from popular undergraduate physics textbooks. So if you're someone interested in physics and learning about it, I think you'd benefit greatly from my channel. Okay, now into the problem. So 2.22 is essentially just practice with the delta function, and where the delta function really shines is in integration. It makes integrals very, very simple. So let's start with part A. The integral from minus 3 to plus 1 of x cubed minus 3x squared plus 2x minus 1 times the delta function x plus 2 dx. Now, in general, what you'll want to know is this. The integral of some function f of x times some delta function shifted a is equal to f evaluated at a. So in this case, our a is negative 2. And this is the function f of x. So our integral is negative 2 cubed minus 3 negative 2 squared plus 2 times negative 2 minus 1. I'm just plugging in negative 2 for those x values. And this is equal to negative 25. And that's the entire integral. B is the integral from 0 to infinity cosine 3x plus 2 delta x minus pi dx. Again, our a is pi, so this integral is just going to be cosine of 3 pi plus 2. Cosine of 3 pi, since that is a odd integer, it's negative 1 plus 2, which is just 1. The only tricky part here is c, which is the integral from negative 1 to 1 e to the absolute value, e raised to the absolute value x plus 3 delta x minus 2 dx. So here's what we need to understand a little bit about the delta function to understand what this integral evaluates to. You might be tempted to do exactly what we did in the last two parts, which is say x is equal to 2, and our answer is e to 2, e to the power absolute value 2, which is just 2, plus 3, e to the 5th. But there's a subtlety here. Your delta function is going to be 0 everywhere except at one point. So the reason why this property works, there's proof behind it, but essentially your delta function is a graph, and I'm sure you've seen this. It's 0 everywhere except at a, where it spikes. Everywhere else, your delta x minus a will yield 0. So what you need to recognize here is this delta function spikes at x equals 2. So on the interval from negative 1 to 1, it hasn't spiked yet. So your delta function is just 0. Well, if this is just 0, clearly the whole integral is then 0, which is what c is. So there's a little bit of subtlety with part C. I could see how that could trip someone up. Hopefully that makes a little bit more sense now. And if it did make a little bit more sense, please like the video and subscribe.